All right, I'm gonna grab some coffee. Oh man. Dang it. All right. So these are these are kind of what these are the goals that I had last time, and we didn't really get to a whole lot of them. One of the things that let's see, I need to do really fast is let's go to this folder view and then let's go to like Team Explorer. Let's do a sync. Oh, okay, so apparently, okay, never mind. Just making sure that I had everything up to date here. I don't know what the diff is here. I wonder if I can diff it. Oh, we have tons of changes. Why doesn't it recognize this? I don't know. Arcs main. Day 3. We'll just go ahead and push that. Oops. No, thank you, Server Explorer. Solution Explorer. Okay. So, let's start some abstraction today because this has been really actually pretty decent for for like some demo code. Let me get another copy of this open. So let's see what we can do here. I wonder if this has support for like Euler angles. Of course, it's not gonna give me. From axis angle, look at, rotate. Oh, they're oh, nice. They're Quaternions. Nice. Okay, this is actually really nice. Okay, good. So, some people don't like Euler angles. I do. So there's a point, matrix 4, matrix 3. I'm just trying to find vector 2, 3, 4. There's a ray. Okay, so what if I did like geometry? What's this? Not what I was looking for. Okay. So let's try to just create just like kind of an abstract object here that we're going to be able to move around. Then we can attach some geometry to it, and then we'll basically just test to see if we can make our cube some sort of object. So let's see. So we'll do rocks. Then we'll try to do just keep a namespace going here. We'll just call it core, and we will add a new interface. And we're going to call this guy. Well, let's just call it a rocks object. God, why is the template so awful? View. How do you format? Is that really what my defaults are? No way. Gross. All right, hold on. Text editor, CSharp. That's right. Tabs, spaces, smart, advanced. Code style, hooray. Okay, we don't prefer this. Let me get this bigger so that I can. This is just for suggestions or whatever. Okay, that's fine. Formatting. General indentation. New lines. No. Same line. Same line. Perfect. Okay. Spacing. This looks fine to me. Wrapping. Okay. So now what happens if we format? Should... Of course, it's not going to do anything because why would it? Really? Did it just forget all the settings that I just saved? Is that a bad joke? What? Like, why did it change that back? Fuck off. So. So let's just write a brief note here. Abstract object instance in a rocks simulation. Okay, so this is just basically going to be, so this, I think we want to have some things that are going to be like, maybe we can do like, so like void rotate. So axis and angle rotates the object by axis by the angle. I need to figure out this, if it's radians or degrees. I'm just going to put a question mark here for now. So then we can do like a move vector 3. And this is not going to be a move 2, this is going to be a move. What's up, man? we'll call it delta. Yeah, it does that to me. It does that to me all the time, actually. But you aren't that behind. I've probably only been streaming for like 10 minutes. And most of it's just been me grabbing coffee and whatever else. And then we can do a move to for each version of these. We'll say position and void move to, and then float x, y, float z. Okay, moves to an exact coordinate. We're just kind of prototyping out. So let's do look at, and we'll do, what is it? Vector 3 target, and vector 3 up. Rotates the object to look at a specific target. Let's talk about what else we can have here. We probably need some properties. So that's the namespace I'm using. So rocks is the title or the project name. I'm just calling it rocks because why not? And core is just going to be the package that houses all the kind of abstractions of the project. So in this case, we're creating basically an abstraction of a thing that can move around in our scene. And then from there, we can build a camera, we can build a cube, we can build any of these things. And what we're going to do is we're going to decouple the geometry from the object. And it'll be kind of one of these things where we can attach any sort of arbitrary functionality to this abstraction of this thing in our world or in our simulation. So common properties, we'll do region properties. So these little pragmas here, these little pound region, they're just, it's completely, they're not compiled, they're compiled out, but they allow you to add like sections of your code. It just is an organization thing. So I can say methods, and then I can go down here and I can say end region. And then I've started another one here, and down here I can say end region for properties. And basically it just allows you to do that. You can just minimize it all and then you can expand it. It's just a nice little IDE trick. And so here for properties, we probably want like a vector 3 forward. And we will define a get for this. The current forward direction vector. And then also up. Those are the two common ones. The current up vector. Up direction vector. Well, not really. I'm not actually 100% positive how the region stuff is implemented. Um, but yeah, I'm sure the IDE is pre-processing pieces of it because it already has to process it for code completion and stuff like that. So I think it's just probably just latching onto the regions. That's all it does. That's all it's for. I mean, we can look it up just to be sure, but let's see. Region lets you specify a block of code that you can expand or collapse when using the outlining feature of Visual Studio Code Editor. And that's it. I mean, it basically is just a region. It gives you some general rules, like it can't overlap like an if block or an if pragma. And then these are actually real pragmas. I think you can also do stuff like this, like warning. So you can supply warnings. That's actually kind of neat. This would show up as like a compiler warning, and then you can also do errors. Yeah, I mean, yeah, exactly. It's not really a language feature, which I agree. That's kind of strange, but you know, I mean, this is Microsoft's baby, so you know they can do whatever they want. So let's see. I think we'll want to have a matrix 4, and we'll just call this the transform, the full transform, and we'll have a getter for that. The current transform matrix for the object. I don't know how much we care about like individual rotations and stuff. We haven't really jumped in. I mean, I looked at it yesterday, the Sonic Pi, the music synth or whatever. Yeah, I actually completed a run, and I missed my PB by 4 seconds. It was pretty bad. I had a great run, and just I torched it at the end. But yeah, I checked it out. I didn't like dive into it because I went straight to bed afterwards, but I looked at it for sure. Okay, so let's use a quaternion here for rotation. We'll have a getter there. Current rotation of the object, instead of having like a full-on. I love quaternions just because, especially like, it's not even really micro optimizing yet. We haven't really started like super optimizing, but like they're just so much cheaper than matrices. Let's see. For now, let's just have a vector 3 position. I don't know. I'm gonna try everything I can to, but I don't want to push it too hard because I found that like when I was growing up, anything that my parents wanted me to do, I just automatically assumed it was not cool. But I so like inside, I so want her to learn how to program. I just think it's such a good skill to have, just a good general skill. Even if she's not like does it professionally, I just want her to like understand at least some of the basic concepts of it. I think it's a huge benefit, especially today, and her generation undoubtedly will will benefit from it. So let's see here. For now, we're going to leave this. This is what we need. We're just going to keep it here. We're just going to keep it at this. We're not going to do anything anything other than this. So, anything that we're going to consider, you know, an entity in our scene, it's going to be one of these. So let's we may extend this further for like camera objects. For right now though, let's just keep it at this abstract base thing, and let's I'm trying to think how we want to do this. Let's create like a render. And then let's create a new class. And I guess, do we want to call it camera? I mean, because camera is going to be an object, but it's going to be a little bit. Why is it defaulting to that? Let me see if I can change this. Hold on. So that's the namespace. The namespace just refers to a qualified way to reference a class. I.e., if you have two classes named thing, but they're in different namespaces, you can use the namespace to resolve them versus there was a default. Let's say that, let's call it, dang it. Maybe I can do this. I hate how they do this. Like, Microsoft wants you to start your namespaces like in the root project folder, and that's not okay with me. Yeah, so one thing that I like about C# namespaces is like, and I cannot even remember what Java namespaces are like exactly. Why is it mad about this? You can't have anonymous namespaces? Okay, well, we'll just get rid of that then. So we're just going to go namespaceless for the startup class because we're just going to expect that nothing else has this. Okay, so this is our render. We're gonna add a camera, and that camera is going to be an IROX object. And it should, yes, there we go. It auto imports. The other thing you can do is here the shortcut is Alt Enter or Alt Return, and I'm gonna hit it. It's gonna give me this little context menu right here. Implement interface. This is what I love about today's IDEs. Is you can just hit implement interface, and immediately it's gonna implement every all the prototype that I just added. Oh shoot, I forgot. Properties go up top, and methods go below the properties. That's a convention thing. That doesn't actually matter, but so this kind of stinks. I like this new syntax that they've added, but this isn't. It's not really what we're looking for. I can explain that later, but essentially they added some syntax sugar that lets you, if it's a one-line method, you can just shorten your syntax. You don't even have to use brackets anymore, which is you know, I like it because it resembles the lambda notation they have, but there are not a whole lot of cases where you're going to end up with like a one-line method. I mean, sometimes. Depends on what it is. I'm not going to make a blanket statement here. Anyway, I probably at some point can locate the settings for this and just have it actually generate full methods rather than these weird stubs. But right now I can manage this. So really, actually really what we want to do is this. Really we want to kind of create a base object as well. And you're going to find that I'm not too keen on subclassing and hierarchies of classes, and I know it's a very popular form of object-oriented programming. I've just always found that it's a road that just causes more problems later than it does benefit you. But this is one of those cases where I feel pretty strongly that that's going to drive me crazy that I have to delete that namespace every time. So what we're actually going to do here is we're going to make this abstract. We're going to implement typically an interface you could consider an abstract class to some degree, being is that an abstract class is just one that you can't instantiate. And it basically provides prototype methods and properties. But so this is one of these weird cases where we want to generalize something as a rocks object, but then we realize we want to share a bunch of that code as well. And I'm always on the fence of how to best handle this. I think really what I want to do is not have this object extend this, or not have this object implement this interface. But since it does, it makes sense to. Like there's no reason for it not to. And in fact, you could almost get rid of the interface completely. But in terms of conventional object-oriented programming, we're gonna keep it like this, just for now. If we decide we want to go back and clean it up later, we can. Extract generic object. All right, we'll say rocks object implementation. I don't mind. I wish it would inherit my documentation from the interface. So one thing to note here is that we have these gets here, but we have not defined any sort of setter. So right now these are read-only properties, and the other thing you'll notice is in that here we have private, and actually what we want these as we want these to be protected, because we're going to want our subclasses to be able to set them as well. What's up, Waffle? How's it going, man? So let's talk about maybe some. So we'll just define some variables. Oh my God, insert, please, God. I normally don't talk on this, or I normally don't type on this keyboard, and my locating the specific keys is being rough. So we're just gonna have a generic, we're gonna have a boolean here, and this is just gonna be our dirty flag. Anytime that we update something like rotation or position or any of that stuff, we're just going to change the value and we're going to flag it as dirty. We're not going to actually update it right then and there, because the only thing that matters in this object is the state at the time that we go to access it. So if we set the position and we set the rotation, we set all these things, we don't want to actually apply that geometry or those rotations or that position or any of that stuff. We don't want to apply it until we have to. And so we're just going to flag, this is going to be our flag. We're just going to, anytime that we make any change, we're just going to flag it as dirty. And then separately, I think what we want to do is we want to keep a separate dirty flag for rotation. And I'm not sure I'm going to get into that yet, but that's going to be more of an optimization than it is like a general yeah, Waffle. Of course you are. So let's actually move this on this look at method down here. I want to just kind of like move through these as like, so let's see here how we want to do this. All right, so let's talk about maybe so let's see, constructors here we'll have just a default, and then we'll have a vector 3 position. Kind of. I'm more or less I wrote a prototype before that kind of outlined the direction that I wanted to go. So I'm kind of following that, but it was written in a completely different language, and so it's not like a one-to-one. So let's see, we're gonna have this, and then we'll have rocks object, and then let's see, we want maybe vector 3 position, and maybe Quaternion rotation. So this guy is just going to call our other constructor, and we'll say with position and Quaternion dot 0. Yes. And this guy is also going to do vector 3 at 0 and Quaternion at 0. So if we don't pass any arguments to our constructor here, it's just going to pass 0, 0 for the rotation and the position. If we pass our position, it's just going to pass the position and a 0 rotation to this one. So everything's going to eventually funnel down to this constructor right here. And then this one's going to be, we're just going to do position. Just going to set it straight up, and rotation. 0 rotation. And depending on actually, we're not going to use this rotation dirty flag because we're not going to. We don't have the ability to update specific. So I have rotation. So I think this is what we want to do. We want to. So I believe that we are going to want. How do we do this? How do we do this? I think that we can just multiply that out. We can just multiply out the quaternion and the. Okay. I wonder if rotation we can. Okay, so you can totally get a rotation matrix from that. Okay. So what we've done is, and actually I believe that I can probably just run it without too much. So what we've done is we just started in this single file, this rocks main. It's the initial class that you start with. It's the initial the code file that you start with, and what we've pretty much done, we've installed a single library that we're going to use, and it's actually using OpenGL. It's using native OpenGL, SDL2, which are both native libraries, and they have C# bindings. And so we're using that, and we've installed these. We have our main, which is pretty much just creating a window. We're creating a shader program, which is a GPU program. It's just it's like a program inside of a program that we're going to compile and upload to the graphics card, and the graphics card is going to run it. And so we're just going to send it information. It's going to run the shader on the geometry, and it's going to actually render things to the screen. So what we actually did though is last week what we were figuring out was combination of here's the matrix, the 4x4 matrix for this thing. It includes transform, which is just position, and it includes rotation. How do we apply that to everything in the scene, or how do we send that information to the shader such that it moves things around in the scene? So all of this is math. I mean, it's discrete math is kind of the basic area of mathematics that kind of applies to this particular I guess section of geometry. This subset of geometry is discrete math. It's basically rotation matrices and eigenvectors and a bunch of other crazy things that I don't really remember that well, but Basically, this is the application of that. You have things in 3D space, and there's this mathematics that you have to apply that transforms things from 3-dimensional space into a 2-dimensional image on your screen. And it involves your graphics card. And your graphics card is very cool and dynamic because it lets you write awesome shader code that is completely in a different completely different language as CSharp. This is GLSL. And it's really simple. It's very dumbed down. It only provides like the stuff you would actually need. So so the basic building blocks of a program don't look like this. This is just kind of vomit. We're just basically just writing a ton of code that does things, but this is not manageable. Long term, you want to be able to abstract out pieces of the code. You want to take things that, let's say, you have a cube object, right? The easiest thing to do is just imagine, okay, well, how do we abstract out something that's all this code that pertains to the cube? Well, you pull out the things that you're constantly applying to it. You make a generalization of it, and which we're calling iRocks object, and then you allow it to attach any geometry. So now our camera can use that same code, or we can make any sort of objects. A player will use that same code. Like you just basically you can abstract something and then you can reuse it and reapply it in multiple areas. And so that's where we are now. We've written all this test demo code. We've played around enough, and now it's time to actually start building the architecture, which is going to be our game. And we're going to move very slowly through this because you don't have to get it right the first time, right? I mean, this is the beauty of programming is this. We're not engineers building hardware. We're not architects building, a skyscraper. Where you have to get it right the first time sort of thing. Like we get to constantly revisit this. And if something doesn't feel right or the pieces aren't exactly fitting the way that they should, then we can, people like the common term is refactor. You just refactor, you change pieces of your design such that you end up with a better, more maintainable, flexible design in the future. So that's a lot of just buzzwords and nonsense. So but that's essentially what we're doing right now is we're trying to figure out, we're just kind of guessing right now, because that's really what you do. You just kind of guess that this will be the best way to use this, and then we'll kind of reevaluate as we progress to it. So right now we have this rocks object. We're going to write all this code that will move it to a position, rotate it, look at another thing. It'll do all this stuff, and then we'll be able to define a camera as a rocks object, and we'll be able to move a camera around. Now the camera will be all of this plus whatever we need the camera to do. So you just kind of like continually build on these things. But it's good to have a good basis. That gives you a lot of projection out into, you don't have to spend a lot of time on design. You write one good abstraction, take you a long way in terms of what you can do after that. So, without further ado here, let's run this just so I can show you kind of where we are. And what we've done is basically just move some things. It's going to be mad at me for something I just... Is it mad because I removed... It's mad because I removed the namespace? Give me a break. There we go. So, let's try this again. Hey yo. So basically what we've done is we've separated our viewpoint. Our viewpoint is just static. It's not moving. And we have this cube. And the cube consists of, how many sides? 6 sides, 2 triangles a side, so 12 triangles. 2 triangles put together makes a quad. So if I could, the best way to demonstrate this is like this. So oh, this isn't great, but it will have to do. So this is one part of our quad, and 0175. God, I'm so good. I remember that. And then this is a quad, and a triangle is that, and a triangle has 3 vertices, and a quad has 4 vertices. So, but a quad has, well, we'll say 4 vertices, 2 triangles, but 4 vertices. So it makes sense, right? I mean, this is sharing. Now, there's a lot of ways to do this, and sometimes when you start rendering complex geometry, you would immediately assume you should share all vertices. So like if I have a vertex here and then this triangle also has a vertex, well, if they're both in the same position, then you should just reuse that same position. But what can happen is that you need different properties depending on where it's coming from, what vertex it's going to be drawing to or interpolating to. You can want the duplicate vertices, but we'll get into that later. We don't have that. But so we can say that this is either 4 vertices, or we can actually call this 6 vertices. But since that one is shared and that one is shared, we can call it 4. Anyway, so each one of these tops is 2 triangles. And what we do, the graphics card is amazing because it comes in 2 pieces, vertex shader and a fragment shader. The fragment shader is just gonna basically fill in the tops. So what we have is we have like a light source up here, a made up light source. And as this thing moves, it's calculating a couple things. It's calculating the angle from the light source to the object at the location, at the specific location. And then it's determining the intensity, and the intensity is based on the distance from the light source. So we have direction and then also distance, and use a dot product for that to get to get the angle, and then you multiply the angle by the color and the intensity, and it gives you this nice, pretty, diffuse lighting on this object. I can kind of show you where we do this. So the things we pass in, light position, and then the end position is and the normal are from the geometry. That's coming from the cube geometry. So, and these are our out variables. So these are the things that we'll pass to the fragment shader. So this is the vertex shader, this is the fragment shader. Everything comes through here first and then goes to the fragment. So what we do here is we calculate the translated or transformed position of the vertex. So the geometry of an object doesn't have any of the transform or rotation applied to it. It's basically just a set, like at the origin. Like our cube is just right at 0, 0, 0. But when we pull the transform information from it, we say, okay, well, we need to move that position. So because the GPU is so efficient at doing all this math, and we don't want to have it on the CPU, we let the GPU do all this work. So it's taking vertex and it's translating it from this 3D space into pretty much the world space. Or camera space, I guess. Well, it's world space because we haven't applied the camera yet. So we basically calculate the normal and the vertex after that. Then we get our light position. The light position doesn't actually have to be translated because we're already assuming that the thing we pass in for the light position is already in world space. We subtract, this is our direction, this is the light direction, and then we find our dot product, and because this value can become negative depending on the normal, we have to clamp it from 0 to 1. So the least value is going to be 0, and the maximum is going to be 1. We get the distance and we divide by 20. This is just to kind of scale the light intensity to a reasonable amount. Like I could remove this and it could be too high and everything would just look super bright. So we scale it a little bit just to ensure that it's not too powerful. And then we pass all of this up to the fragment shader, and you can see we have our light color, which is going to be, our color is blue, clearly. And then we use our cosine theta and our light intensity and our color, and then that outputs at that specific location on the cube what the color value is that. And then we let the GPU, it actually shades everything in between. It's really nice. It goes like tessellation or something. I think that's the right term. I'm actually going to look it up to make sure I'm not just spouting nonsense here. Yes. The process or art of tessellating a surface. So basically the GPU understands, based on the value or the color of this and the color of this thing, how to smoothly fill in the differences. It understands what, if it's moving from here to there, how it should fill something in. It's really neat, and probably way outside of my understanding. So we'd have to get a hardware engineer to explain that sort of thing. So let's move back to this object here, and I think a good goal that we should go for today, and I'm going to try to get there in the next 20 minutes or 25 minutes, is let's try to render this same cube, but let's try to attach the cube to our object and have it rotate and move that way. And then that will give us kind of a jump start into like creating a scene and then adding objects to the scene and that sort of thing. And you know, we haven't really jumped a whole lot into the voxel part of it yet, but we're very close to getting there. Once we kind of establish, okay, here's how we render things. This is the pipeline which we're going to use to constantly push geometry through, and this is how we're going to manage our objects and that sort of thing. Then we can start looking at creating, you know, the individual voxels and the terrain and that sort of stuff. So let's go back to this rocks object thing, and let's just basically, this is what we want to do. So if we want to move something, let's just say that this is, actually though, I think we're going to need backing variables for all of this. So vector 3 up. So we'll have up, forward, I think we can get from the, we can get both of those from a rotation matrix. So actually I lied, we don't need that, but we do need a rotation matrix, I believe. So we're going to have a rotation matrix, and what I'm trying to figure out is, So when we apply these changes, so move what's up, Max? How's it going, man? So our position, we're gonna offset by delta, and then we're gonna flag it dirty. And then we're gonna do the same thing here. Position. Plus equals y. Why is this angry? What do you mean it's not a variable? Are you serious? Is that something new? Well, let's just do this then. X, Y, Z. Move to, this is gonna actually set it. Position. We're gonna say dirty. Move to, we'll do the same thing here. Vector 3, X, Y, Z. It's not super, the 22 years. I've been programming for about 22 years. I've been professionally programming for about 10. Hi. However, I mean, there's no range on this. I mean, hopefully all my experience is going to give me here is just the step on running into horrible issues. But there's no getting around that stuff. Just remember that, you know, the programming is a skill that takes practice, like anything else. And I am admittedly very out of practice when it comes to writing these full-blown game engines like this. Like, I'm very out of practice. I haven't done it in probably a few years. So this is my chance. What I personally am getting out of this is just some sharpening of my skills. And I was telling Bo earlier that one of my things is just, I feel like community programming is a big deal. So I feel like it's just share it. I mean, there's no reason not to. So I'm going to post some more stuff about this as we continue, but there's a GitHub for this, which I probably need to start including in the description. But there's a GitHub repo for this, which I should post now, actually. Then I'm just going to be committing all this stuff. I think it's MIT license, so it's basically you can do whatever you want to with it. Yeah, it's MIT license. If the license becomes an issue, we can make it so that anybody can use it, take it, steal it, whatever. Just stick with it, man, because it's hard. It's hard stuff. Like, you'll find that it's like anything else in life. There's something that you see people who are experienced are really good, and they're just practice. They're veterans. They've worked at it. But literally everyone who programs struggles. There's no non-struggle programmer. I mean, it requires such intense, focused thinking that there's no way that anyone can just sit down and, hack the world. Just stick with it. There's going to be a million things you don't understand and don't get it at first. And I would say focus on doing specific things. Stack Overflow is also your friend, but don't use it like as written truth. Use it as kind of a guide. But other than that, man, practice. Like, just sit down and write something. Think of some project, and don't make it too lofty, but think of some project that you can start out small, and if you want to add to it, you can, and if you want to start all over, you can, and you don't feel like you've wasted your time. Like, it's something that needs constant practice, but you don't want to burn out. And those are the two things that, if I have to give pro tips, it's practice, but don't burn out. And it's easier said than done. And Bo is exactly right. Keep it small and contained. And that way you can actually finish something and you have this rewarding feeling like, hey, I just built something that did this and I want to do it again, but maybe next time I want to do it this way. So when you sit back down, think about the problems that you had with the first thing that you wrote, and you can skip ahead. You know how to handle those problems. You know how you would do it differently. And so you write something and then you do it better, and then you write it again. And there's this kind of myth that people will sit down and just write the most elegant, beautiful code in the entire world that's bug-free, and it just doesn't happen like that. I mean, good programmers write tons of mistakes. The difference is good programmers can go back, recognize the mistakes, and then have great ideas about how to make them better. And they iterate and iterate and iterate. And eventually you get this nice, stable, elegant piece of software. Anyway, that's my theology here. I'm done. Let's get to writing out some of this stuff. So, Quaternion from axis angle. Beautiful. So we're gonna start. Why do I keep hitting insert, the most useless key ever? Rotation equals Quaternion. I don't even know that I pronounce this right, Quaternion. I believe I am, but it is essentially what it is it's a very useful compressed version of a rotation matrix. Bo, I'm sure you do. So dealing with problems is a completely different thing. Debugging is not easy, but start by identifying the problems, and then go through each one in kind of order, right? Which one seems to be deep rooted and won't go away? And what you'll find, I mean, it's not always, but sometimes if you fix the one kind of nagging problem that feels like it's just won't go away, and you track it down, you find where it starts, and most of the time when you find a deep rooted problem like that, it's either 2 seconds to fix or it takes you a long time. And sometimes you just have to evaluate how things are laid out, and what's the best way to approach it. But you'll fix that one issue and you find that everything else just kind of goes away. I mean, that's the typical experience, to be honest. And then also, once you find that one issue, you find the other ones. You'll either find the other ones on the way to finding that one, or I mean, it's just one of these things that it's like anything else. Like if you're building a castle and you have a bad block at the base of the castle and the whole thing is lopsided, and then you also realize that other things look lopsided because of the original lopsidedness. All you have to do is fix that one stone and then brush up and clean up some of the other things, and then all of a sudden you have a nice working app. Don't give up on the problem. My number one tip there is don't give up on the problem. It's frustrating, but pick a time in your day where you really want to focus. Find a nice quiet place. Go take your laptop, whatever, sit down, focus on the problem, fixing the problem. And if you might fail 20 times, but don't stop. Like that's finding that issue will be so rewarding when you do, and you will learn. You inevitably learn more from tracking down and fixing the issue than you ever did reading a book, reading Stack Overflow, writing code in general. You will learn more finding and fixing a bug than you will actually writing code in the first place. Just saying. That's, again, theology here. So a quaternion is a nice little compressed way of, since a matrix is a 4x4 set of numbers, it can be quite expensive if you have a lot of them. And so a quaternion is just a way to store an axis angle in basically 4 values. And they're magical. I mean, I got a math minor, so my knowledge about mathematics is very limited here. And I'll be honest, I don't remember a whole lot of the math. Oh yeah, no problem. I mean, like, and the thing is, man, is to one his own. And like, your style and the way that you approach problems may be completely different from mine. I mean, I can tell you how I do it, but I'm not any sort of, angelic programmer or anything. Like, I just approach problems this way. It's been helpful for me. So, that's how I do things. And you might have a completely different approach to it, and that's perfectly fine. There's no right or wrong way, I don't think. Whatever's effective. So I think that we can. Oh, the angle is first. Angle, axis, and then at this point, we can also flag this dirty. So as we're going along, you see we're making these changes. Now I don't have, because this method. And I found a bug right there. So move to is just going to call this other move to, which is setting our dirty flag. So we don't actually have to set our dirty flag here either. Because if we did, it would basically, we get here, call this rotation, would set it, position, it would set it, and then we set the dirty flag. If we added one down here, it would just be doing that twice. So that's why I don't have dirty flag sets here and there, because they're already calling these methods that flag that. And you'll notice what we're doing is we're just creating these things and setting them. We're not actually applying anything. We're just updating the state. And then look at here is going to be a little bit different. Well, I think it's going to be a little bit different. Okay, so look at, we want to get, I wonder if I can get a look at from this. I can't. So let's see, I can from this though. Create look at, wait. Okay, so this is going to prove to be not as awesome, but let's see. So rotation matrix. We're actually, what we're going to do is we're going to start that as dirty. We're just going to say it's dirty at first, because what we're going to do here is we're going to call update rotation. We're going to set these things, position and rotation, and we're going to call update rotation. This update rotation is going to be called whenever we need to like bake everything together. So we set all our properties and everything else, and then when we actually need to get something, we're going to say if dirty. So we're going to check to see if our flag is set. So if we don't have any changes, there's no reason to do any of this work. So if this is, or we're going to cut it off. We're going to say if there are no changes, we're just going to immediately return. We're not going to do any more work. We're just going to return. In the event, if we've made it to here, if we're here, there's no, then dirty has got to be true, right? Because if it's false, it's returning, so it's got to be true here. So that's like an early return block or early conditional or whatever. There's probably a nice term for it. So at this point we know we're dirty. So what we actually want to do, I believe, is we want to take this rotation matrix that we have, and we want to use our rotation quaternion, and we want to create a matrix 4 from it. That's what this is going to do. So we have our rotation, and we get the matrix 4 object from our quaternion. That's going to give us an actual rotation matrix. And then we can set dirty to false, I believe. And we probably want protected void. We probably want also an update transform. And we'll add this just in case we need it. So if we ever need to forcefully update it, we can. So, and then for this one, I'm going to say if we're not forcing it and we're not dirty, then we can return. Same sort of thing. And so let's see. So let's figure this out real fast. So update rotation, and then we're gonna, since this is actually gonna reset we're gonna update transform true. That's gonna force it. And you know what? We can probably do this as well. So instead of being kind of weird and setting the dirty flag early, let's add a force there too. If not force and not dirty. Okay. And logic people, I think we can get rid of both nots here and do not force or dirty. It's the other way to spin it, I guess. So we set our dirty flags, we have move, we have rotate, we have updates, and interesting. So that's our transform. So we want to keep, so we keep this all separate. That's the trick here. So this is what I didn't necessarily realize at first, but now I got it. So we have a we're gonna have this return that transform. Okay. Our transform matrix, we're going to initialize. We have to initialize it here to matrix 4.identity. So just setting it to the identity matrix. This is matrix applied to any other thing. We'll just give it the same thing. So it's basically just a way of initializing something to not do anything. But those who are and those who have been through any sort of discrete math know what an identity matrix is. And so what we're doing here is we're going to keep object rotation separate. Now this is debatable. This, you could argue this point or not, but we're going to keep object rotation on one end. We're going to keep the look at rotation as a completely separate force. We're going to keep the transform of the object, how the object's transformed, and the actual rotation, what we're going to call the rotation, just how it looks in 3D space. We're going to keep that as a completely separate matrix. We're not going to bake all of it just yet. We will, but we're going to keep them separate just for just to leave the option open. So let's see. So those are, we flag all that dirty. Just making sure we're getting to a point where we can actually move on. So this transform, we want to, I thought look at. Okay, I thought so. I just got really lost. We don't need this. Get protected set and identity. Okay, good. This is going to create target. Whoops. Our I position is going to be the position of this object. So we're going to use position. Then we're going to pass the target and the up vector. And we're going to change that to transform. And then at this case, we're, actually, so I think I told a little fib. I think what we're I think we're going to have to return this because I'm looking at my own old stuff and I'm pretty confused at what the hell I was doing. I thought I understood what I was doing, but clearly I'm incorrect in that assumption. So it sounds like I was full of it earlier. Our look at is actually going to apply our rotation here. But it's confusing me because I assumed that's staying. So what do I use that for? Just forward and up? Yeah, I'm pretty I'm pretty lost at this what I did here. It just looks wrong. Although I'm really surprised because a lot of this has worked for a long time. So What it looks like I've done is I can bring this on screen, but this is this is basically my rocks object and my prototype. Is that I have our update rotation here, but I have this separate rotation matrix, which I use things to like get the forward vector and the up vector from. And then I have the separate transform, this guy, M transform, and it's used for look at, but nowhere does that transform ever get set to that rotation. Which is why I made my original statement that we're keeping the rotation and the transform matrix completely separate. But really, that look at matrix should absolutely... Oh, you know what it is? It's because this matrix right here contains position and rotation. It's the full transform. And what's tricky, we're going to have to figure this out later. I'm not going to put any substantial amount of thought into it on the stream right here, but I'm going to think about this and we're going to come back and fix this. Because what this means is that when I use look at, it's going to start using this transform matrix. And ultimately, and this transform matrix is a baked matrix. It's basically taking the position of the object and it's taking the rotation and it's melding them into one matrix. Rotation here is just one rotation. But we don't really have any idea of which one it's using because, so when we go to actually render something, we need to know which one it's using. So, and this is what I have here. I have look at, and I have position plus forward, and then I have up, and then dirty equals false. So this updates rotation, this updates transform. Somehow I've managed to keep them separate, and I am either going to figure that out later when I go through here, or okay. Enough about this. This is I'm confusing myself here. This is exactly what I'm talking about. No programmer is excused from confusing themselves. Right now all this is pretty basic though. I don't think we've gone I don't think we've gone one direction too far. Let's see, our rotation matrix is just going to be... Why don't I return that though? That's what's bothering me, is I don't have anywhere that returns that rotation matrix. That rotation matrix is just literally finding forward and up. Let's figure out, forward is just going to be so our forward vector is going to be, we're going to have to up, because we're requesting the most up-to-date information here, we have to update our rotation. So we're going to update rotation, and then we're going to return, hopefully this rotation matrix has a, what in the world is this? How's that deprecated? What does it want me to use then? I think forward rotation is the first index of the matrix. My math is so rusty. We'll just do this. I think this actually unit z, but then we have to normalize this. So we're going to return that, normalize. Okay. So what we've done here, well, I'm going to give these a default value. Of false. Okay, so this is going to be something similar. So essentially what we're doing here is we want to get the current forward direction. Now, this is where I'm a little bit shaky, because it seems like you could get this forward vector from either the transform or the rotation matrix. And what really would be optimal is if we have a transform that our rotation matrix is just the extracted rotation piece of our transform. But since we don't have that, I'm not gonna really, we're just gonna hope that we're gonna use transform for right now. Or matrix, I guess. I mean the rotation matrix, sorry. So what we're doing is we have this rotation matrix that's created from the rotation we currently have, and unit y. And we're going to take our default up and forward vectors, and we're going to multiply them by a rotation. That's going to give us our up and forward vectors for this particular rotation. I'm running really short on time, and I want to finish this. So let's make this not abstract for right now. This is going to be kind of breaking my own rules, because if it was abstract, I wouldn't be able to instantiate it. Abstract classes can only be inherited. And let's go to our main, and let's just create one of these bad boys. So let's see, private rocks object, and let's actually use the interface. And let's make sure that namespace, let's call it rocks object. We'll call it cube. And our cube, so we're going to create a new cube here, and we're going to just say new rocks object. We're going to pass it the position, which is going to be new vector 3 0 0 0. We're going to put it at the origin, and it's going to default to no rotation. So here's our geometry, though. That's going to remain separate for right now. So here's where we're just coming up with a rotation value. And we're going to offset. So here's where I'm applying all this stuff. So I have a rotation that we're going to use. I'm going to erase this, and we're going to say cube move, and we're gonna move it 0, 0.05, and 0. And then here, we're going to move it in the negative direction. So this is all code that we had. And remove this position, We actually probably just want to get rid of this completely. Let's get rid of that position because our position is now stored inside of, oh, that's cool. So we want our camera, this is our camera code, to look at the position of the cube. That's what we want it to look. So we'll grab that position value from the cube. I guess we should have defaults here, but I don't really like that, but it's fine. We can figure that out later. So the cube geometry was going to remain separate. The geometry of the object and the geometry are going to be different things. The object's going to have properties of basically physical pieces, like where it is in the scene or what it's rotated, or we can add more things later, but it's going to describe how to present the object. The geometry is basic. I mean, it's going to be, you can change geometry, but the geometry is just going to be the visual representation of that. So it's not going to actually change continuously. Like with voxel stuff, it's different because you will modify the actual geometry. But with our specific case, we're going to detach what the state of the object is, which is Rock's object, and then the geometry will be a completely different piece. So we create the geometry separately. And then we're going to say if cube.position at y is greater than 3, we can skip cube.position.y. So here's the fun part. So cube rotation, what we're going to do is we're going to say cube dot rotate, and we're going to provide it a rotation axis and the rotation amount. Now the rotation amount is incrementing by 0.05 every time. I think that I finally understand what I was doing here. Let's see where update transform. Can I make that public somehow? Let me see, 1 second. I think that I did. I think that that is why. Yep. Okay. So this is why. Although I guess we want to update the transform right after this, though. Okay. Anyway, I'm sorry. I've gone off on a tangent. This was not as modeled. This was not modeled as well as I would have liked before going to this, and I probably should have reviewed it before I came in because it's the source of much grief at this point. So our model matrix here is going to be cube transform. I hope. And this should give us our full, we're not even going to set it to a separate matrix. We're just going to set the value directly. So our view matrix comes from our camera. Our model matrix comes from our cube. And hello. How's it going? We're going to hope this works. Of course it doesn't. Why would it? Why would it work? At least it didn't explode, but it didn't work. So why didn't it work? That's the question. So when we call rotate, so that is why. That is why. So I'm going to go back one more time and say this. So matrix 4, we're going to have a transform matrix. It's going to be separate. We're going to set it to the identity. We're going to make this a getter, and we're going to update transform. I think that we should force it for now, and then we're going to return the transform. So when we actually request okay. Make sure I have this right. We can remove it from here. Okay, this should work. Hooray, it does. So I don't want to go into the crazy details because the reason why it is the way it is because when I prototyped this thing, I created a camera first, and then I created a bunch of objects that like basically repeat a bunch of the code. So it was like copy and paste almost. And when I went back to clean it up, I was like, oh, I need to abstract out an object from the camera and all these other things. And I pulled stuff out. And as I pulled stuff out, it ended up being kind of hacky. Because the camera needed to update transforms at one point and the objects updated transforms at a different point. And so it didn't all look nice. So I'm basically looking at the base object that I came back later and changed. And so what we're really doing here is the rotation matrix just tracks rotation separately. When we actually want the final matrix, we take the up and the forward vectors created by the rotation. So like if you can imagine, let's see, I'm going to point this way. If you can imagine this phone pointing directly, this is like at 0, 0 pointing at the camera, and so it's no rotation. Now, if I rotate this way, we keep track of that in a separate rotation matrix. And when we decide if we update our transform, we ask for our full position and rotation matrix combined into one. What we really need to do, all we need to do is really take the position and call look at in the forward direction. So like looking at this way. So our rotation holds that. That's where we get our forward and up vectors. And so it's applying it from that. But what I didn't have is code to actually force update the transform, which is what we added. So on that note, I've got to bail. I got to get the real work, but it's been a real pleasure. Hopefully you guys enjoyed it. If you have any questions, please drop me a line. Let me know if you want to see something specific or you want to see something over again. Let me know and we can review it the next section. And I will see you guys very, very soon. I'll have this updated and uploaded ASAP. Talk to you guys later.